Hello guys, I hope you are fine. In the last lecture we studied the concept of histogram where we studied what is histogram and we also studied the types of histogram based on the skewness where we studied about normal, positively skewed, negatively skewed, and we also studied about the histogram types based upon the modes we studied. Now we will going to implement all of these concepts in our coding stuff. So for this what we will do, we have to implement this in the coding. So I'll go to my search and here I'll type VS Code. VS Code. So if I click VS Code, my VS Code will come, and here I created one file called as histogram.py. See, I will tell you one thing. Whenever you want to visualize something, you will be using two libraries, Matplotlib and Seaborn. But for this video we will be going to use Matplotlib only, as this Matplotlib usage is very easy. And for creating data in table format, this you will be using Pandas. So that's why we will be going to use both of these particular concepts. Now what I will do here, first I will install both the libraries, pip install Pandas Matplotlib. So now you see that requirement is satisfied, means this is already installed in my system. So now after this what I have to do, I have to import this Matplotlib. So import matplotlib.pyplot as plt, and we will also import pandas and as a pd. Now what I will do, now here I have to create the data first and convert it into data frame. Means what? In the form of table you are converting your data into. So now converting your data into data frame, what you have to do, you have to create one variable called df. In like any variable you can create, df, data frame, data, any variable you can create. But for now I am writing the value as the df, and in this what I will write here, I will write pd, means the pandas we are using this object. Here we will write data frame, and in the data frame what I will do, I will create a dictionary. So don't worry guys, I will make one shot video of how you can able to use the concepts of pandas, and I will create one short video of numpy, pandas, matplotlib and seaborn we will going to create. So now here in this what I have to write, here I have to pass a key. So means column you have to pass. So here age I will pass, let's say 18 I'll pass, 19 I'll pass, 20 I'll pass, 21 I'll pass, and suddenly I will pass the value as 90. Okay. Now 21 I'll pass. Okay, for now I will be going to keep this particular 20 only, and in here I'll pass salary. So in salary what I will pass, salary I'll pass 10,000, 20,000, 30,000 and 40,000 I'll pass. Correct. So you have created the data frame successfully, and you also have created this particular thing. Now if I print this df, let's say, so now how the data will look like if I execute this particular command, you see that now you see this data is stored in the form of table, that is in the form of row column. So to convert this data into table, that is in two-dimensional table, we will be using the concept of data frame in pandas. So now what you have to do, now you have to plot the plot. So for now you have to, let's say first what we have to do, we have to print for the skewness, histogram based on skewness. So in skewness what I will do, here I will going to pass, here I will going to plot my first thing. So what is my first particular plot for the normal distribution? So for my normal distribution what I will do, here I will just pass plt dot plot, I will going to say, sorry, plt dot hist I will going to say, and in hist what I will do, I will do one thing here. Here I will pass as one more age here, and here I will going to pass one value as 30,000 itself. Okay, I will going to pass some value, and remember this thing works if the age, let's say having 5 records, then salary should also have the 5 records, then only this concept will work. If you didn't write the value, it will print it as empty and your accuracy of the data will be lost. It will give the dash, means the data is not there. So the problem might come here. And so here I will again write the value as 20 itself. Okay. Now here what I will do here, here I will plot the histogram. So in histogram what I have to pass, I have to pass my data, and here I have to pass. What is the bin value I can pass here? Since we are having the 5 records, so what I will do, I'll just pass the bin as the 4. Okay. Now here I will also pass the title. So what title I have to do? I have to pass it as normal distribution curve, normal distribution. And now if I print plt.show, and if I execute this histogram again, and here if I put comment to this line, and if I execute this line, and if I click enter here, now you see that this particular plot has formed like this, where this represents the x value and this represents the y value. But we don't want like this. We don't want the data to look like this. We only want that proper histogram should form for it. So that's why what we will do, instead of this particular age, we will just keep the value as salary itself. Okay, we don't want age. We will only keep the value as salary. So here I'll put Control C. And if I execute this code again, now you see that here the data, if you see, it is there in the skewed normal form, where the mean of the data will be the center part of the data. Like let's say if I want to calculate the mean of it, so here I'll write df.mean if I write, let's say, and if I want to print it, then it will give you the mean of this data. So if I execute this thing, command C, and if I again execute it, see, mean is giving the 26,000. So means what, near in the center part of the data your mean is there. From the mean right hand side and left hand side, both of them the data will be same. That's why this type of data is called as the normal distribution. But now comes the second type of data, that is the skewed data. So first we will write right-skewed. Okay, right-skewed means what? It is a method which from where we can able to detect the outliers from right hand side. It is also called as the positive skewed. Now skewed. Now here what I will do, here I will just pass the salary. Here I will create my data frame again. Here I will going to comment this out, so that if I execute this thing you should not feel the problem. So here I'll command it, and now in place of 40,000, here I'll pass 90,000. I'll pass this. Okay, so here you see 10,000, 20,000, 30,000. I'll pass one more 30,000, and here I'll pass one more 40,000. Okay, so now what happens now, if I print the data frame here, now if I print df, now if I click on this, now you see that the salary is in the form of proper row and column format, correct? So now what you have to do, you have to just plot this particular plot. So for plotting, what we will do, we will again write plt.hist, and in the histogram what we'll pass the df. Here I will write df underscore right. Here means right is skewed. So here I will write df underscore right. Here I will write df underscore right. And in this what I will do, here I will going to pass my bin value. So total how many are there? Total 8 are there. So here what I will do, I will deliberately pass the value as 7. So now what I will do, here I will write, if you want to give title, you can give the title as right-skewed. And after this, what here, if you want to execute it, you have to write plt.show, and once if I click on this histogram.py, this is there. And now you see that here the data, if you see, it is properly in the form of right-skewed, means here the data, like here the one particular value is there, this particular value is an outlier. So if you see here in this data, you see that this particular thing here in the data is an outlier here. Is an outlier, as it is the extreme value. So that's why this value is an outlier. Since this value you are seeing in the right hand side, that's why it is called as the right skewed data. Similarly, if you want to show the left skewed, so here what I will write, instead of this, I'll just copy this thing, and instead of this, here I will write left, and in the left what I will write from the left hand side, means it is a negative skewed. So if you see the direction of this particular thing, it is in the right hand side. Now here it's in the left hand side. Now what I will do, I'll again going to copy this thing. Here I'll going to paste in the thing. Just we'll going to change the data from there. Okay, to make you understand the difference between all of these three. So here what I will do, here I will pass my value as 60,000, 70,000, 70,000. Then here I'll pass 80,000, here I'll pass 80,000. Okay, now if I print this particular df underscore, if I could change the variable as df underscore left, and here also I'll pass df underscore left, and if I change the title as left skewed, please ignore the spelling guys, this happens with me frequently. Now you see that this particular thing here, the outlier is found in the left hand side, means here the outlier is present in the left hand side. So that's why this type of skewed is called as the left skewed. So I hope you understood the concept of implementation of skewed via using the Python. Now we'll going to see the histogram types based on model. Okay, now here I won't be using any data frame concepts at all. I will just take the value very simply. So now here in this, what I will write, I'll just write the data here. I'll pass some values. Let's say here I'll pass 10, 20, 30, 40 I'll pass. Now here what I want to display this particular data based upon the model. So here if you want, you can convert it into data frame. This is your choice. So now if you want to convert it into data frame, then here I'll write data frame. Here you can write pd.data frame, you can write, and here you just pass the data. Like this also you can able to pass. Now if I print the data frame here, now here I will comment the above code so that you won't feel any confusion in that code. So here I'll press command slash, and now if I execute this particular histogram.py, you see this particular command is been passing here. If you want to specify the column name, you can directly just write as column name. Here I will pass it as some value I'll going to pass. Okay, this is the way you can able to pass the column name, as here above 0 is there. Now here if I enter this histogram.py, here it has given the error that this is not the correct way to enter the correct column name. So okay, no problem, we will leave this for now, and we will just write pd.data frame. We will just write here, I will it should come like this. If I execute this again, now at this particular column, these are the values that we have. Now our major objective is to print the unimodal data. So first we will going to take the unimodal data only. This is the unimodal data that we are writing, and now you just want to display this data. So display the data. Now here what I will write, same plt.histplot we will going to do, and in the histplot what you have to do here, you have to pass the data frame, and in the data frame you have to pass the bins. Now here see total how many values are there, 1 2 3 4 5 are there, but we have only 10 20 30 40. So either you can pass it as 5 or you can keep it as 4, no issues. This totally depends upon your choice. Now if you want to put title, here I'll write unimodal data, and plt dot show function I'll going to use. And now if I click on this particular thing, I will if I execute this command, now you see that here only one particular peak is there. Since in your data you have only one particular peak, that's why it is called as the unimodal data, correct? Similarly, you can able to create it for the bimodal data. So for bimodal data, what we will do, bimodal data. So for bimodal data, here I'll pass this particular data itself, and here I will write I'll pass 150 I'll pass, and 50 I will pass. And here what I will do here, if you want, you can display you can convert it into data frame, or this is depends upon your choice. So here I will use it the same variable, but I will change the variable for bimodal, and now here I will execute the same commands like display the data, and in place of unimodal I will just pass the bimodal data. And if I write underscore bimodal, and if I execute this command, if I comment this out, if I just execute this particular command, see now here you see that there is some problem has happened. Now this problem came because you have played with the value of bins. Now what happened here, you have kept the value as 4 but you have multiple values. So total how many values are there? 1, 2, 3, 4, 5, 6, 7 are there. So keep value always 1 less than. So we'll keep the value 6 and now I will execute. So what I did, I kept this one value less and now we're going to execute it. So once you're going to execute this particular plot, now you see that you are having the 2 peaks. So always whenever you want to play with the mode, always play with the bins. So now if let's say if I write all the values as 7 also, I will tell. Now if I want to execute this particular command, now also it is coming. So there is no problem of playing with bins. You can play with n number of bins. Here if I write 15 also, now what will happen? It will divide the data into 15 different parts like I discussed in the last lecture. Now you see that here also 2 modes are there. So in the last, if you play with the bin values, you will get the mode. You will get the 2 peaks are there. So this is called as bimodal data. So I hope you understood the concept of bimodal data. And the last type that comes is multimodal data. Means more than 2 peaks if are there, then it is said to be multimodal data. Very simple. Now here what I will do, here I will pass this, and instead of 50-50, what I will do here, I will pass 80 or 81. I will pass one more 80. And here, if you want to display the data, if you want to convert it into data frame, you can use. I'll copy the same command and I'll go and execute it. Here I'll copy this. I'll copy till here, and I'll just paste it here. And in the instead of bimodal, I'll pass multimodal. And now if I write here also, I'll pass multimodal. And here I write multimodal data. And listen, always play with the bin values because your bins plays a very important role in statistical analysis. So if I execute the value as python histogram.py, now here you see that here you have here, because here we didn't commented out this particular thing, that's why this particular graph has came. So we'll comment it out. Now here I'll press Ctrl C, and if I execute this command, now you see that you are having more than 2 peaks are there. So whenever you are having more than 2 peaks of data, then it is said to be multimodal data. Now here I will change the bin values and we will check. Let's say if I keep the value as 10, total how many are there? 3, 6, 9 values are there, correct? So if I execute this thing, here you got the 3 as the value. So from 1 less than value, you should always try. Let's say if your length of the data is 6, let's say, try from 5, 6, 7, 8, you can play with n number of bin values. So your bins plays a very important role here. Now here if I give the bin as the 5, you won't get the multimodal data. In fact, you only get the bimodal data. So always whenever you try to, let's say first you have to find the length of the data, and let's say if your length is 10, your bin should always start with the 9. Always. It will give you the good results. It will able to distinguish you between the model data, bimodal, unimodal. It will able to do it. So that's it, guys. I hope you understood the implementation of histogram via the coding part, where first what we did, we used these 2 modules. So why we used pandas to convert it into, to create the data into tables, and Matplotlib because for data visualization we use this Matplotlib and Pandas, sorry. So don't worry guys, I'll create one-shot videos for you guys to explain all of these concepts. Very easy, not that difficult. And then first we played with the data, where we implemented the normal, then right-skewed, then we implemented the left-skewed, and then we played with the model data, unimodal, bimodal, and multimodal data we have played. And there is one more type of model is called as uniform model. When 2 peaks come at the same range, when all the data comes in the same range, it is said to be uniform. So here I'll tell last thing is uniform. So in uniform what will happen, here I'll take the value as data, here I'll take 10, 20, 30, 40, 50. And now if I go into plot plt.hist, I'll go into plot. Here I'll just pass the data. Bins total, what I said, you should always start from 1 less than, And now if I click execute this option, and if I could comment it out this, and here I'll put title as uniform, and if I write plt.show, and if I execute this command again, now you see that from 40 to 45 here only one particular peak is there, but it should not come because you divided the data into 4 different peaks. Now if you just now you saw what happened if we keep the value as 4. Now what happened if I keep the value as 5 here? Now if I execute it, now you see that the entire data is uniform, as every point, every thing in the data, the point is unique. That's why it happened. So that's why your bins value plays a very important role in distinguishing the data. But generally if you don't want to use any bin if you don't want to use, if I just write print data, you will see what it will take. If I execute it, it will show all of the unique data. Why? Because this history will have by default value of bins. Now if I go to Google and I will check, let's say, like what is the by default value of bins in Matplotlib histogram. If I type this, now it will tell me the value. By default it will take the value as 10. By default it will take the value as 10. Always remember, by default histogram always take the bin value as 10. So I hope you understood the concept of Matplotlib histogram. Here you see, if you go to this website, it has told what happen if you keep the value as 5, and but by default Matplotlib uses the value as the 10. So you can go to this website, you can go to the official website, and you can study the documentation. So like this you can able to implement the concept of this, all of these things. So here in this uniform you don't have the clear peak, because here the entire data has been uniform. That's why it is called as uniform data. So I hope you understood the concept. Any doubt, please feel free to ask in the comment section. Please do like, share and subscribe guys, and thank you guys.